Welcome back to another beautiful day of Leetcode practice. Yes, I know it's been a while. No, I do not have an excuse. Let's continue. Okay. First and last position of element in sorted array. Lovely. Given an array of nums sorted in non-decreasing order. Okay. Who wrote that? English is not your first language. What the heck is non-decreasing? You mean increasing? Sorted and non-decreasing just means that you guarantee the numbers are not decreasing. Does that mean they could be in a random order as long as they're not decreasing? Whatever. Anyway, find the starting and ending position of a given target value. Okay, so duplicates are allowed, I guess, and then yeah, okay, so like sevens. Okay, 8, so there's an eighth and another. Okay. Write an algorithm with of log n runtime compile. Oh, come on. This is just, I hate these. It's like the other one that I did the other week. It's just binary search, and then you have like some extra minutia beyond that. Like, okay, if you can write binary search, you can pass like half of all Leetcode questions, apparently. And I hate writing binary search from scratch. Particularly the recursive variant. Um, it's I don't know. All right. Okay. Fine. 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 But mm, I wonder if there's any optimization in Java. I'm sure other languages have this, where there's there's an index of where you tell it that the array is sorted and it does a binary search. Because I know Excel can actually do this. You don't expect this out of Excel, but when you do VLOOKUP, if you tell it that the column is sorted, the performance is like significantly greater because it uses a binary search and it finds a much. So yeah, I mean, I wonder if Java has the equivalent for arrays. I'll have to look into this later so that I can just use that anytime somebody asks me about binary search. I'll just switch languages to whichever language has that, just so I don't have to write a fucking binary search from scratch. Okay, public static int, we'll call it bsearch int nums in target. Now we only need to find the first occurrence to get started with this bad boy. Yeah. Returns index of target -1 if not found. Good enough for government work. Binary search. Oops. See, I'm already messing up. I'm already messing up. It's not something you do often. Like, I know that maybe coming out of college, you're like, oh, who can't write a binary search? Like, I never do this at work, so why would I? Like, I'm never writing a binary search from scratch. Why would I possibly do it? It's silly. I have functions to check for containment. I have index of and stuff. The performance of these is relatively decent. But this one says all of log n. And, on the last one I was able to pass Leetcode. It's like, automated runtime detection. But like I said, like at the time it wasn't really log n. So technically if the interviewer was being a stickler, they could have been like, nah, you didn't do a binary search for the pivot or whatever. And then that's not good enough. Sucks. It's a -1. Almost screw that up. See, there's all this little minutia too, and you're zero indexing and stuff. All right. Okay, and then these are the recursive steps. Okay, so if it's bigger than the target, then it must be to the right. Must be to the right, and then otherwise it must be to the left. Must be to the left, and then, okay, move right. Yeah. It's better not to slice your array. So you want to take these as args. See how complicated? So tedious. So tedious. I'm just a stickler for putting the params in the comment. I've had interviews before where I've done the Java docker, written it, and they're like, oh, you don't have to do that. And I'm like, yes, I do. Yes, I do. I'm a professional computer programmer. And even if I'm in an interview, I have to do that because I'm a goddamn professional. Nums to what do you take as the start? Is it the same start? I feel like it's the same start. The same start, and then the end is no end. Something like that, right? Yeah. Then the Bobby search, nums target. I'm just so frustrated by the prospect of writing a B search. I still can't get over my rage. Oh, I did that wrong. It actually goes from mid to end if it's to the right, and then it goes from start to mid if it's on the left. Okay. And then when do you terminate? I forget. How do you know when you haven't found it? Is it when they're equivalent? Is that what it is? I want to say that's the term condition. If I think that's the term condition for binary search. Something like that. I don't know. We'll figure it out soon. Yeah. Let's just test this. Let's put some stuff in there. Find out. That's only the part one. I mean, this is finding the first position. Then you've got to scan left and right to get the rest of the end. That's pretty easy. Okay, so I'll move this over here. Right here. Get the placeholder in there. Nice. Oh, really? Java doesn't have that syntax? Do you really have to do this? Crikey. Oh man, what is this even? Is it like that? Yeah. Ugh. Gross, Java. Why'd you make me do that? Ugh, I feel sticky. Int out equals new int. That's gross. Java, why? You know, every day we stray further from TypeScript Lite. That's funny that that's not the syntax when you're doing this. That's funny. I forgot a comma. I meant a period instead of a comma. Period instead of a comma is a funny common mistake, but mixing up I and J is another funny. I love that they teach people to use I and J in college. It's such a bad choice of index. I always go with I and N or I and K, and then there's no problems. Found, and then I'm gonna go with research nums target 0. Nice one. Why is this so like, why did this turn white? Oh, it just wasn't going to fill in the color until I filled in the print line. Okay, whatever. Yeah, obviously this isn't the answer. I just want to test my B search. Let's see if I'm getting the right indexes. See, I got Stack Overflow error. That's not a good thing. You want that one. Oh, right, they can pass each other. That's a possibility. Still Stack Overflow. Gross. Huh? Why is this? Oh. Yeah. TypeScript plan. Yeah, it's usually not a good sign in the interview when you can't write B search from memory. So, but you know, everybody makes mistakes, and whatever else I need to say to make myself feel better about not being able to write B search from memory. It's just that I'm getting the term condition wrong, I'm pretty sure. I wonder if it won't output for me. Yeah, shoot. Oh, that's funny. It just continues on. Which one does it get jammed in? 4 mid, 5. Yeah, that should be fine. What is that? Which test case is this even? Nah, it doesn't matter. 0 to I guess it does matter. Oh, that's fun. How does that work? Whoa. It's so beautiful. I'm kind of confused though. How do you do this? I liked the old one better. I like the tabs better. No, you know what? Oh, I don't know. I don't know. Okay. Well, anyway, it's the sign's backwards. Nums of mid is less than target. Stupid. Stack Overflow. Why did it find 3? Which test case is this running? Oh, that's the index. 0, 1, 2, 3. Yeah, that's correct. Is this just running one test case after the other? Ah, yeah, probably. So that would be the second test case then, right? Yeah. Right. Oh, yeah. Okay. No, when do you stop the B search? So, oh, right. You don't need to include mid in your search, so you can do, you can start at mid +1, and you can end at mid -1. There's no point in including that index in your search. Okay. Okay. Finally got binary search. PhD computer scientist. Took me a while. Okay. That's basically it solved though, because now I just do the walking step. And we're good to go. Oh, that's funny. I got half the test cases right already, just by virtue of having nothing. Okay, anyway. So Found index. I'll keep my print for now. Alright, and now I just scan to the left and right to get this bad boy. So, while I'll just call this int k equals nums of I. Yeah. Oh, int k equals nums of. What do I want to call this? Yeah, I'll call it found index. It's kind of stupid, but. I'm just going to go with this. While nums of k equals found index k minus minus. Let's be more specific than this left. So here we will walk to the left, and then we'll do right. I wish you could just have the binary search to start with. That'd be cool. Can you ask the interviewer, hey, can you just give me one of the, like, I know how to write binary search, but can you just give me one so that I don't have to waste 15 minutes of this interview? Okay, I also have to account for out of bounds. And nums is less than, oops. So I walk to the left, stop if I go off the edge, or stop if I encounter a character that is not the what I'm looking for. And I walk to the right, do the same thing, and then Bob's your uncle. Out of 0 is left, out of 1 is right. And we're done. You might ask, why didn't I write a comment for this one? Good question. Okay, I'll get some more. Well, I guess I'll run it for the 3 test cases I have and see if it passes the. Okay. I made a mistake. Oh, I guess you want to stop 1 short. Yep. Yeah, what's the best way to stop 1 short of the end so you don't go out of bounds? So if it's equal and stepping 1 more step won't take you out of bounds, then you step 1 more step. Yeah, if it's equal and there's another step available to take the step. Right? I think that's correct. Still out of bounds. Oh, is it my binary search? Yeah. I have a binary search go. How does that? Oh. Wait, no, can't have binary search go out of bounds. It's weird. Start -1. The only way I can start at negative what? That's a left seeking one. It's mid +1. What? Right. Okay. Why is that what? Left 4. I forgot a space. Okay. Oh, what is this? What is this? Did I forget something here? How do I get -1 here? What? The heck? How do you do that? Oh, that's bizarre. Um, get a quick return here. I don't know. I don't even remember what'll happen to my edge case there if it's empty. I might need to handle edge case 1 too, but I'll do that later. Uh, yeah. So what's up with that? Start with 0 to 5, and then next one shit's -1. Oh, 2. It's just bizarre that it jumped to -1. It shouldn't have altered the start in that case. Uh, so that's outside of this business. And this worked fine actually for the first test case, I think. 0, 1, 2, 3. No, it should be 3. Because, let's see, it found 4, and then it should have moved on to 3, right? Da, 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 da. Oh, if it's not -1, obviously I want to get out of there. Okay. Whoops. So 0. Huh. So all this only happens in the event that you find something. I missed that part, so I was doing some scanning on -1. That was unnecessary. So that was where that error came from, I think. But it still doesn't explain why my binary search got to -1 over here. What the fuck did it do there? Okay. I mean, it was still accurate in the sense that it got the right answer, but it shouldn't have done that. So it started there, and then it went to the left, but it managed to alter both the start and the end. Just confusing. I printed start, mid, end in that order, right? So it should have sent nums, target, start, and then it should have updated the end, which it did. The end should be the mid -1, which is 2. That's correct. 0 plus 5. 5 divided by 2. 3. We already checked it, so we go back to 2. That's good. And then, where's the -1 come from? I'm so confused. Did I? Maybe. Oh. Yeah. Well, when you're copy and pasting from another IDE, I guess you get what you deserve for not paying for Leetcode Premium. There we go. Yeah, that makes more sense. Yeah. Yeah, that's more accurate. Okay, lovely. And then that also works. Yes. Okay. So found 4, left, right, 4. Okay, so that's wrong. It should have scanned up to 3. So it's nums of left equals. Oops. Stupid. I'm not looking for an index. That's stupid. I'm looking for the target number. Duh. Stupid. Now it's 1 off, right? So I want to stop just before that point. So I'm going to do the index check first so that this next bit doesn't go out of bounds. And it's left -1. This is a cool Java trick. Not all the languages support this, but like Java and JavaScript do. Or if the first statement in an AND evaluates to false, then it doesn't evaluate the rest of them, which lets you prevent out-of-bounds issues easily by just validating the boundary in your first check. If you validate the boundary in your first check, then it won't continue, and you'll be good to go for the others. You can also wrap everything in a try-catch like a real programmer. All right. Let's do one for a single number that I'm searching for, and one for a single number where I'm searching for something else. The single number case is down. Yeah, see? Wait, that's not the right answer? Oh, I got the wrong answer. I got the wrong answer? How? My binary search broke again? My binary search is so goddamn jank. Okay, it escaped too early without checking the find condition. God damn it. I suck at writing binary search, man. I'm gonna go hit the books and get the best goddamn binary search in the world so I can really knock this one out of the park next time. Stupid. It's such a simple algorithm to describe, but I don't like any of the solutions in terms of how they're written, in terms of neatness. Binary search. Let's do another few. Let's do it's all the same number. That's a good one. What else? What else? What else? What other weird ones could I have? Can't really think of anything bizarre. It didn't say I have to support negatives. It says integers, so technically, yeah. Oh, no, yeah, negatives. Could be negatives. It should be fine. Yeah. Guess I'll do one where there's like a different number on the front, and then one where there's like a different number on the end. Maybe those are kind of sneaky-ish. Okay, I'll just submit this. If there's anything wrong, it's going to be my binary search. Nice! Well, did it! What's the time at? What do we got? 28 minutes. That's actually normal for a medium. I don't completely suck. Not completely. Okay. So did pretty bad on the runtime, did pretty bad on the memory. Let's just take out the print statements and see how I do. Last time I did this, it wasn't much of an improvement, so let's see if it is this time. Maybe my B search is not as fast as it could be. There's something there, I don't know. Yeah, I don't really see anywhere where it can be improved. I guess less memory, maybe. I don't have to pass the target repeatedly. It's Java land, so you could store the target in globals, and then I wonder if it even it probably counts towards your memory. But it's a lot less memory because you don't have to jam the stack frames up with your target in every single generation, so that could help. Yeah, I could do the same with the array, probably. Put it in global storage, then you're only using one copy. I mean, it's not good programming, though, because you just have an unnecessary global then. It's confusing. So I wouldn't do that unless I was just trying to code golf my way out of this. Okay, I guess I use this temp var. I might not need this. Let's see, do I actually need that to handle empties? I don't really think I do. I think my B search will fail. No, it won't, yeah. Because I'll do nums of length -1, and that'll fail. Yeah, I think I need that. Yeah, reallocating these two spots might be a little memory cost, but not a lot, honestly. The left and the right thing, I don't think that's a big deal. Seems pretty low cost. One variable. It's nothing. I could do both while loops at the same time. I could step left and right at the same time. It would look uglier. I like that better, so just like that. Yeah, I mean, this is fine. I'll see without the print statements. Maybe it's reasonable. Oh, yeah. Okay, so just the print statements, keeping the man down. And then in terms of memory, I guess yeah, move those couple things to global. Nums and target could be global. I mean, I could even do start and end globally. So just when you're doing recursive calls, every time it calls itself, it puts all those variables back on the stack frame. So when you're playing memory golf or whatever, trying to get your memory as low as possible, let's give it a shot. Let's try it out. Try it out. This is dumb. I'll do it here first. Do 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 do. You're allowed to put brackets in the name like that? Oh, right, it's Javaland. You can put the brackets after the name. Pew pew, do whatever you want. Pew pew. Not every language lets you do that. That's fun. Maybe I should have named them the same thing. Yeah. There we go. Now we're doing good programming. Okay. And now this takes no arguments. I guess inlining it, actually, could probably be an improvement. No, no, you can't because it's recursive. You can't inline it. Oh well. I thought about it. It didn't work. Oh, right, no arguments now. YOLO. Okay, so it's start equals mid plus 1. No change to end. And then here it's end equals mid minus 1. No change to start. And then we just recurse. Right? Yeah. And now we have no variables on the stack frame because they're all sitting pretty in heap land. Lovely. Look at that. Such good programming. Oh, forgot to do this bit too. Memory efficiency. Let's go. I think this will do well in memory. I think this is about as good as it gets. It did worse? Oh man. I guess Java's heap allocations just aren't that good. I guess that's not actually an improvement. Oh, I put the print statement back in. Hang on. Hang on a second. Accidental print statement. Changes everything. Aha! Nope. Worse than memory. Damn. Bad trick, I guess. I guess static allocation. Bad. Static bad. Oh well. Let's undo this. I want to keep my right answers for posterity. My posterity, not yours. Not that I can't just watch them in the video or anything, but hey. Alright, and get rid of my print statements and my answer too today. Alright, well, that was easy. I hope I get this one in an interview, because this one was fucking easy. Easy squeezy lemon pea. So was the last one, though. These were both easy, because these are just binary search and then do some stuff. The last one was maybe a little harder because there were two fragments that were in order, and you had to figure out which fragment you were in. I didn't even write the binary search for that because I wasn't feeling it. This one, it's just regular binary search. What's the big deal? It's super easy. Easy squeezy. Lemon peas. Let's replace my solution here as well. And get my final score here. This is the one I'm going with. I'm 100% runtime, 21% memory. I think I actually did better last time I submitted with the same code. But anyway, all good. I'm happy with it. Nice. Okay. Thanks for tuning in. More Leetcode next time. Later.